Hi again, this is Mr. Ford, and today I'm going to show you how to draw Lorenz curves. So previously, you should have done work on interpreting Lorenz curves. The fact that it's a curve that shows a quality line here, and then there's another curve of your data, and the further away it is from that line, the less equal it is in terms of distribution, or the more concentrated the data is. So more concentrated on certain individuals or regions, it matters on what your data is. So there's steps here now. This I've given you steps for it, but a Lorenz curve works on very similar principle as cumulative percentages, or like a cumulative frequency. So if you remember, you'll have cumulative frequencies. That is another. If you think of the word cumulative, that's very much like to accumulate or to gather. So a Lorenz curve works off cumulative percentages. Okay. So the steps are, we'll be turning our data into percentages of the total, how much of it exists of the total. We'll be ordering those percentages from lowest to highest, okay, or from highest to lowest, matter on the data that you're doing, okay, matters how you do it. If you do from highest to lowest, it will be above the equality line. If you do it from lowest to highest, it will be below. It doesn't matter because it still shows the difference between it as long as you make that decision. We're just going to plot it on a graph and then make sure we draw the even distribution line, which is a straight diagonal line to show how far it is away from it. So we're going to do that on this one here. So I've inserted this here because this is a unit you will be doing on percentages. So just to highlight, to find percentage of amount, all we have to do is we do the amount that we've got divided by the total times 100. This turns it into a decimal, but times by 100 turns it into a percentage. Okay. So what we've got is we've got data of the population distribution and the amount of land it occupies. So in the UK, now this is from 2014 data, a little bit old, but it's still good. So in the southeast, there was 8.6 million, and it's got a land of 19,000 square kilometers. London has 8.1 million and a land area of, or well, not even 2,000 square kilometers. Northwest, so northwest up here, 7 million, but it has 14,000 square kilometers and it goes through them here. You may already notice that the population is in descending order, so we won't need to actually do that step and rank them because it's already been done for us in this example, but you will have to do that for whatever one you decide. Okay, now let's have a look. The first one, we need to find the percentage. What's the percentage of the population in the southeast? If there's 8.6 million and the total percentage is 53, so the percentage of the population will be 8.6 over 53 times 100. Okay, put that into a calculator and I get 16%. All right, next one, 8.1 over 553 times 100 is 15%. And I do that for each of these. Once I've done this, I'm going to then do it for all of my area. Now, just to make it easier, I'm just going to pause it. I'm going to write all these in, and then I'll come back to you. Okay, so I'd like you to pause it now and actually do this for yourself. Okay, so if you need to check, you can now take a moment and you can actually take the results here. But I've just done percentage of the population out of the total population in the UK and written them in. Now, like I said, Lorenz curves works on a very similar application of cumulative frequency, but instead of frequency, we're now doing cumulative percentage. So we're going to accumulate percentages as we go down here. So the first one is 16%. Then from the beginning to here, it's going to be 16 plus 15, which is 31. Then from the beginning to there's two ways we can do it. We can either add up all three of these, or we can do because these two add up to 31 plus 13 would give me 44. Okay, and you just go through the process of adding those up. Now, there is some rounding errors in here, so I'm going to just add those in as well. So we have 56, 67, 77, 87, 95, and 100. Okay, you do exactly the same for here. Now, there's a rounding error here as well, but it's just 70. Okay, and okay, just because I'm doing this with rounded figures and this is without the rounded figures going up. So, and I'm going to do my graph based on these. And that's it. We're going to do exactly this. We're going to use this as our x value and this as our y value. It goes from 0 to 100 and 0 to 100. So let's look at how we're going to do that. Now I've got my cumulative percentages. I'm going to plot them. Okay, so we'll go to the next one. Oop, my graph has disappeared. Let me just get it back. Okay, so I've got a grid here. Now we're just going to draw it. So let's count again. We're going to count out how many boxes we've got. 1, 2, 3, 4. So there's over 20 boxes across and 20 boxes up. So let's just put our point here. This is going to be our initial point. And let's say 10, 20, 30, 40, 50, 60, 70, 80. And you can see how I ran out of gap, so I'm going to redraw it. This is what I mean by gas injector is good. Let's do it from the corner. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, I'm going to add some axes in here. One moment. Okay. Okay. So I'm going to write these in as well. And then I'll be back. Okay. So what I've done here is I've labeled my axis. And I've also put cumulative percentage of population because that's going to be our x-axis because it's ranked. That's our ranked value. And cumulative percentage of land area going up the side. Our first rank was 16% against 15%. Kind of makes sense, which is good because it means it's even. Then we have 32%. This is our cumulative against 16. Because it didn't change much because it's only 1% because it's London. Let's pop that in. Then we've got 20. Then we've got 45% against 27%. You just go through and you plot it, percentage against each other. (77 to 70). Then we've got 87 to 81. And 95, 93. And 100 to 100 to finish this off. So then we connect it. I'm going to use a blue line. Again, I'm going to pause it so I can get a nice smooth, so a line between them. But, okay. So now I've drawn these, and I've also added an even distribution going from 0, 0 to 100. You can see the distribution. Actually, that's not a very big distribution. It's actually quite close to this line at most times, which shows us that there is actually not much concentration in terms of population compared to land area. We do have the biggest distances of these first two. They would be the biggest because they're the biggest distances from the even distribution line. So if we have a look here, those 2 and 3 would be London and Northwest. London and Northwest. London and Northwest. So they are the biggest differences between population and land area. So we can go through and answer these questions now, but that's how you go through drawing them. So it's just like cumulative frequency, but the thing is you need to have percentage, it's cumulative percentages instead of frequency. Now, let's have a look. Does the Lorenz curve indicate a high or low degree of concentration? It shows a low degree of concentration because the curve is quite close to even distribution. As it's fairly close. Distribution line. And which regions account for the most concentration? Well, we have London and Northwest. Okay. Yeah, you could argue this one here as well, but it goes in and that's a little bit closer than this one here. I hope that's helped you be able to draw a Lorenz curve. There's one after this that I want you to do yourself. Okay, have yourself a great day. Thank you.